Okay, so thanks for the intro, Stephen. So I don't have to introduce myself. Thank you for that. I would like to ask you all to briefly introduce yourselves. We've seen some of you this morning. We haven't seen all of you. So shall we start with you, Brent?
Sure. Brent Salisbury. I work at the university and finishing a book right now, co-authoring with Greg Farrow down there, and committer on OpenDaylight also.
I'm Curt Beckmann. I'm with Brocade, and I'm active in the Open Networking Foundation. I've got a couple roles over there. I chair the Forwarding Abstractions Working Group, and I'm a member of the Chipmakers Advisory Board.
I'm Dimitri Stiliadis. I'm with Nuage Networks, and I'm working on the architecture of a network virtualization solution there.
Hi, I am Samrat Ganguly with NEC, and I am leading the SDN and the NFV activities within the NEC.
Dheeraj Pandey, founder CEO Nutanix.
I'm Chris Wright, and I'm here representing the OpenDaylight project, and I work for Red Hat, and I'm helping bring Red Hat into SDN and network virtualization. We're already there for compute virtualization.
Thank you. So I don't know what you probably announced the title of the panel. So we're supposed to be talking about software-defined data center architectures. And unfortunately, almost all of us here are networkers, so that will be the focus.
Except for me, actually.
Okay.
I'm not a networker, so I can bring some.
Good. And the question I'm always hearing when someone is selling, in particular, the overlay virtual networks, let's just throw them into the mix, is, okay, what about the application visibility and QoS and so on and so on? So I'd like to step a little bit back from that and start with a question. Do you think that we need new architectures to deploy whatever software-defined data center is? Or should we just deploy them on whatever legacy gear we have out there? So is this deployable on existing gear, or should we stay with leave the legacy where it is, build something new, and then slowly move from the old to the new world?
Where do you want to start? I could start. Well, so I'm not a networking guy, so I'm going to give my own 2 cents on this. But I think the answer is yes and no, because that's the way the world moves. You can't just throw everything out and start something afresh. As Alan was talking about, there's a lot of legacy that needs to be bridged. And successful companies know how to bridge the legacy and yet talk about the new architecture. The reason why I say no is because there are things that you can't do with everything legacy, because they talk a different language. Like in the world of storage, storage appliances talk in the language that was built for physical servers, like LUNs and volumes and file systems and things like that. Now, you can't use those constructs to really go and deliver software-defined storage, for example, because it's not multi-tenant. You are, for example, you are keeping 100 virtual machines on one LUN, and now one of them got corrupted. You'll have to restore the entire LUN before you can even restore one virtual machine. So there's a huge impedance mismatch between the entities and constructs that software-defined world is looking for and what the physical world infrastructure actually was managing all this while. So therefore, I think there is a need to think through exactly what can be achieved with the legacy infrastructure. Maybe a few things you could scale them out, and then it's important to actually talk about scale out when we're doing software defined. But the other things where you can't have top-down visibility simply because they never talk that language of virtual things, virtual LANs, VXLANs, and virtual machines and things like that.
So, it's hard. So what are network systems? They're a distributed system, right? So I think we've had pretty amazing. Over the past decade, web-scale applications have gotten really good at these things. Just look at something simple like Cassandra, right? So now if you can take that and start, I just think it's kind of this evolutionary process that we're running into. I think the outstanding question will be, is an overlay a bridge, or is that the final answer? I mean, I think early on it just has to be, you know, I don't think they're mutually exclusive of one another.
Well, it's hard to argue with incrementalism and yes and no. I have to. It does seem like that everybody would love to have greenfield, right? Yeah, just give me a big greenfield, write me a huge check, and I'll get back to you. Realistically, even folks that have greenfield opportunities, they have legacy opportunities too. For the most part, they start with something and build on. If you're going to have something that's radically different from the legacy infrastructure, there's got to be a really compelling reason for it, and yet it's not very credible when you can't demonstrate it because it doesn't exist yet. So I think there's that strong tendency toward incrementalism. So you will have these architectures that can sit on, at least to some degree, maybe it's not quite as efficient, but it sits on the legacy architecture, spanning tree, et cetera. And then it runs better maybe in some new architecture. So that's sort of the yes and no and the incremental. Where will it go? Where will it evolve? Yeah, I think, I can imagine it's going to be overlay, but what does overlay mean in 5 years? Maybe it's something different. And then there's this overlay, underlay. How separate are they? Can we debug it just from the endpoints and not have to look at it internally? Probably not entirely, right? So I think that's where, as we really get scaled out and we start to fix problems, instead of just, well, I'll just shut down that rack, I'll just move that stuff over, and then, well, now I need to optimize a bit more and make better use of that equipment that I shut off. Now I got to figure out why it doesn't work.
I think the issue is not so much whether overlays will work over existing data center networks or maybe new ones. The question is, how will overlay talk to all the rest of the network infrastructure, right? So if you create an overlay architecture that essentially creates an island, it doesn't talk to anybody, then what have you done? So for me, the challenge is to make the overlays interface with the rest of the network and the existing infrastructure, rather than where it will work over old or new hardware. It will work fine over any hardware.
Okay. So I think what I am hearing, of course, we hear that overlay is a story which works today. It's flexible, it can work on the legacy, but there is the need for a real fabric which is basically will support the newer applications and the problems that we just kept on accepting over the time. Like, when we have when we want to create like a fabric path which can create like a non-interfering paths for an application basis, like QoS, or different paths which doesn't interfere, like storage requires its own level of services from the underlying infrastructure. Those are the things which the overlay cannot do. So I don't see that the overlay or versus the whole, the new generation of the software-defined infrastructure. I think that this is a starting point where slowly there will be a need for both of them to create a more of a unified control strategy or software-defined strategy, which can leverage both parts and create a more of a evolutionary ground, supporting the new greenfield deployment as well as supporting the existing legacy scenarios.
Yep, I agree. I mean, it's fun to be dissenting in a panel, but we're already seeing this happen. We already see deployments where we actually have customers that are ready to write a check for a full greenfield deployment, and the first thing they do is ask, now how can we connect this to our legacy system? So it's gateways, it's building software abstractions that allow you to connect your sort of greenfield new architecture to your legacy applications. I don't know that in all cases, I think as everybody has said, it's really an evolving process, and we're seeing new requirements in the core, whether it's the networking core or whether it's a desire to reduce operational capital expenses in the virtualization or storage cores. Each one of those spaces have room to evolve and bring forward sort of new challenges that I think is really the fun part of what we're doing right now, is trying to figure out how we can take these systems that are currently historically fairly entrenched, bridge them together, and ideally bring something that lets users actually benefit instead of it just being a lot of hype And I think that we're seeing the beginning of that. It's pretty hard to say where it will go, but I believe we'll have a long tail of bridging between a new architecture where maybe you have a lot more east-west traffic than you traditionally did in your old architecture, but you're going to have to live with both worlds for quite some time.
Yeah, one last thing I want to say is that this is particularly more difficult in networking than in storage. Because networking is, you have to lay out a fabric, they all need to talk to each other, there are all these languages and protocols that need to be adhered to. Storage, on the other hand, and if you look at just compute and storage, they're more silos. You can bubble them. And you can say, I'm going to start with this prototype, and you can make money on that prototype. And then you can make some more money in expanding that prototype into a larger application and so on, without worrying about perturbing the entire fabric. And I think networking has this Hail Mary concept right now, like everything has to work before we can really. And I think we saw this with IPv6, It was just massive. I remember reading about IPv6 papers back in 95, 96. And they had thought through tunneling, and they thought through how IPv4 is going to be used to carry IPv6 and so on. But NAT came and actually said, you know what, you can postpone this for 10 more years before the rollout comes out. So fabrics are just hard to roll out. I think just by the nature of the beast, it's just ubiquitous. Everybody has to talk that new language. Every damn equipment has to change. And for SDN, that's a challenge.
So do you see the overlay networks as the NAT of data centers?
Possibly. Possibly. I mean, I drew an analogy because I wanted to say that networking in particular is just, has a lot of legacy and a lot of bureaucracy and inertia that we don't see in our world. When we talk about software defined with applications and compute virtualization and storage virtualization, people get it because they can start with an application that just works.
By the way, this is an excellent lead-in to the next question, which is sort of focused on storage. There are still people talking about fiber channel and InfiniBand and all these different combinations of these with Ethernet. And as you have demonstrated, it's perfectly viable to have storage on Ethernet. And if you take a look at what the other side is doing, every VM we are deploying has an Ethernet NIC that we need to emulate. So is there room in data center for anything but Ethernet in the future?
Yeah, I mean, if you look at it 10 years down, exactly what happened to mainframes. Like mainframes still have room today. IBM makes good dollars in mainframe even today. It grows at 5, 7, 8% year over year. So people talked about the death of mainframe in 1982, and it's been 30 years and it's still there, So IT things just don't die. They just shrivel and become smaller compared to the rest of the growth in terms of budget. So if you'd ask me 10 years from now, people will still be spending $4, $5, $6 billion on fiber channel and things like that. But the question is, where is the growth coming from, and can this 5 start to look like 4, 3, 2, 1 over time? And I think that's just the nature of the game. I mean, as Alan was saying, that legacy just doesn't die like that. I keep hearing about FiCon every once in a while, about when somebody's still doing FiCon, and I think there are enough applications. I mean, I was talking to a dental provider 2 years ago, and they said that the biggest IT project they're actually focusing on is mainframe to x86 migration. And this is year 2010, 30 years after people actually talk about the death of the mainframe. So things move slowly, and it's going to continue that way.
I was working on a real RFI from a large service provider that said we want to connect VAX machines to the overlay. So,
so again, it depends on what company you are. If you're a vendor that is betting on growth areas, like I talked about Microsoft, Oracle, Sun, and Adobe. They're focused on growth client-server market back in the 80s. They said that's the nature of the game they want to be in, and there were others like JD Edwards or whatever that company that was doing a lot of mainframe-based stuff. They bet on that because they wanted an annuity-based business as opposed to a growth-based business. So vendors can pick whether they want to be in this game of maintenance and annuity, or they want to be in this game of growth where they can go and make more revenue on that.
There's also just a pragmatic kind of cost-benefit relationship where as long as you're getting some value out of it and somebody's willing to make it and sell it to you, it'll persist. So if latency is the most critical part of your data center and you're getting best latency, least latency with an InfiniBand solution, then that's going to stick around for a while. Low latency Ethernet is making inroads, and will it completely obliterate the others? I think it's hard to say, but certainly is going to be a lion's share of the market, in my opinion.
There's a lot of application architecture aspect to this as well, and certainly some applications are able to move from a constant consistency model to an eventual consistency model, and that lends itself more to this distributed storage. And oh, the server went down. Oh well, I think we've got another copy of that somewhere, and we'll figure it out. Versus something like maybe inventory or credit card charges and expenses, where no, we need to have that constant consistency model. So you may see a little bit of a transition, but 16 gigs selling, Gen 5 is selling like crazy, and we're investing in Gen 6 as well, and customers are out there very interested in that and want to buy it, because some of that stuff doesn't lend itself to a move to a eventual consistency model. iSCSI came out quite a long time ago, and people use it, but it didn't displace SCSI over fiber channel, right? So like we said, right, there's times where you want high performance and constant consistency, and you're not going to get that in some of the other models. And if it's not broken, what are we fixing?
Well, so I'd probably argue that the fundamental driver of that is the fragility of data center networks today. Data center, I operate them. They're fragile. Somebody can always come in, plug something in, and burn down a network. On the transition, though, it's so much easier to come in with software, install software, and for that matter, remove that software, as opposed to ripping out hardware and putting in hardware. I just think it's.
Well, I think that's right, but so there's the 5 nines guys that kind of are trying to figure out how to get to 6, and then there's a bunch of other people that are like, 3's plenty, and this is a big gap, a big difference in application architecture and demand and needs, and it seems like economics is going to drive a bunch of people in one direction and a bunch of people in the other direction. I think it's segmentation.
The phrase I use for economics is good enough economics. Ethernet is good enough economics.
Yeah.
That'll eat into everything that's niche and low latency and really low latency and so on.
By the way, your remark brought me to a totally different aspect of it. So you're mentioning 5 and 6 nines. Obviously, software-defined data center is probably not ready for that environment. When do you think it will be?
Back to the economics question. If you can sell it at 3 nines, then maybe there's a niche, virtual private networks or something, where we'll give you a 4 nines and we'll charge you a bit more. That's probably some of that going on already. If you want 5 nines, and how important is it that you save a lot of money and basically you're in a multi-tenant environment? I don't know. I don't know that the multi-tenant SDN or SDDC is going to get to 5 nines for a long time, because I don't think economics is going to encourage it.
Yeah. I think that to a certain level it has to do with what you do with your architecture and how you build the software-defined data center, and from my view, the software-defined network, right? If you build a monolithic system where you have everything concentrated together, trying to control everything that you do in the network, well, it's doomed to fail. Mm-hmm. If you build a system that can federate, can scale, can horizontally be elastic, right? And as you go, you can add more control planes that have a share nothing architecture, right? They don't share anything with each other. They are completely different availability zones. Then you can reach much quicker a 5.9 architecture, right? So it's fundamental on what architecture you use to build your software-defined data center, and the idea of a single brain managing everything and assuming that, let's take Amazon for example, right, and AWS, right? So even in Amazon East, there are several availability zones. You put a single brain to manage all these availability zones, you will never go to 5 nines. You put 10 brains now that federate and they can communicate with each other in a share-nothing model, then you can reach 5 nines. So it heavily depends on what's under the hood here.
I agree
Amazon
to that whole thing.
I mean, just Amazon in general. I mean, it's the perfect example because they build networks to fail. They know they're going to fail. Their infrastructure is going to fail. I mean,
that's all actually the driving the whole, I would say, the virtualization. Because if you look at the carriers, now that they're going into the whole network function, virtualization, as opposed to when they used to buy carrier-grade products from the traditional vendors. But if you now look at exactly the way the design of the architecture, the automation which you can do now, considering different data center level availability, inside data center level availability, you have multiple choices for availability which actually didn't even exist on a very proprietary hardware model. So it's very difficult. It's a very architecture dependent. You have the chance of actually increasing that. But they also found out that with those initial legacy models, it doesn't scale. It doesn't provide the whole economics of scale. But actually here, they did. And sometimes they see into the whole Google and others, they see, hey, they are not buying like the carrier-grade things, but still they're providing very good services. Then what are we doing essentially with that whole model of the past? So I think that's all the architecture. But when we see into the whole carrier-grade NFV architecture, we see there are multiple ways you can take care of the availability zones.
Sure.
Network is just one of them.
I think I would say that there is a theory part of this. There's a practice part of it. The theory is the architecture, and the practice is just the gestation that it takes for any system to just gain the experience and get baked in the field before it becomes robust. So Amazon today doesn't provide any SLAs but 11.9 SLAs for data reliability. They don't provide SLAs for availability and so on. Remember, they've been working on this for 7-8 years now. They started EC2 in 2005-2006 timeframe. So just the nature of gestation that any system has to go through before you start getting those 5 nines actually, independent of the architecture. They have the most scale-out architecture. They don't have any single point of bottleneck. They don't have any single point of failure and so on. So I think that is just the rite of passage that next generation systems have to go through to really say that we can be as robust as a mainframe. You don't change mainframes. You don't write new code in mainframes. So there's less entropy and hence they're more available, But I do want to say that it's not inherent in the SDDC architecture itself that it can be 5 nines, I mean, we monitor our systems constantly across at least 5,000 servers that we run on today, paid systems that customers have. And we have been able to achieve 5 nines after about, I would say, 9 to 10 months of operation. And it's just through a large population of systems, we've been able to, obviously there's this whole averaging game that goes on in this space, in MTBF and MTTF and so on, MTTR. I think it is possible to claim that with enough gestation, you can get to 5 nines in SDDC as well.
Well, it's an interesting question. What are we measuring? Are we measuring every VM, or are we measuring an application? And if applications are resilient, well, you can have a 5 nines application sitting on a 3
Yeah, exactly. And I think if you look at all system vendors do this MTBF, MTTR stuff, based on a population of systems, not just one system itself,
Yeah, I think it's unrealistic to expect 5 nines in the near term for general purpose SDDC orchestration systems because software is fragile. The goal is to build these things out of commodity hardware. Hardware is failing consistently. And while a robust solution includes, like Dimitri described, a federated architecture that allows you to not share state and not propagate failures across your entire system, the convergence times are still high. I mean, 5 nines is not a lot of downtime. So I think
yeah, but you don't measure one system only. You can measure a population of systems, and therefore everybody gets to 5 nines actually.
Everyone fails together.
Yeah, sure.
Call me a skeptic, but I think that applications are more likely to change and take advantage of cheaper infrastructure and sort of expect failure and model themselves to a newer data center model rather than build intrinsic to the application expectation that there's only seconds of downtime per year in the data center fabric.
So the problem though is that if you take, for example, a controller, right, controlling a large data center and you get a failure there, you're going to hit a lot of applications, right? So in reality, you cannot afford to not have reliable and baked systems when it comes to your SDN controllers, your routing protocols, the way you interface to the network. It's not an option or a luxury you have to just say, oh, the applications will take care of it, because if this thing goes down and together with it, it brings 2,000-3,000 servers, it's a lot of applications, right?
Yep, absolutely.
And to be honest with you, I feel confident we can go there because I know we have done it in the past, right? We run IPVPNs with thousands of endpoints there that essentially are virtual networks, right? And these IPVPNs provide 5.9 SLAs. So there is no difference. I don't see any barrier to actually achieving that stuff in the data center today.
I think there's a difference in the dynamic nature of the allocation and destruction of the network element. So in other words, I think
right?
there's more
It depends how it's done.
It's not just the infrastructure, the applications are playing a role here. I mean, Amazon went down, Netflix went down on the Christmas Eve. So whose problem it is? You can't just say it's Amazon's problem, that the Netflix architecture or the applications has to ensure that how you're using the underlying resources. I don't think it's like here my things ends in just the SDDC layer. It's the part which are playing together, integrated. So now applications has to consider that role, but then it can create. It's not that it's not possible, but yeah, like you said, it takes time because you don't know where the paths are going down. I mean, Netflix also didn't know, right?
Yeah. Yeah.
So but they are trying to do something about it.
So if we step a little back, because everyone started mentioning overlays here and there. Oh yeah, I started. And then we more or less agreed that we can't throw everything out and replace it with the new stuff that will do the magic thing. Is there anything other than overlays that's reasonable to deploy in the near term? Because we all know that some vendors are trying to cheat with using existing hardware and encapsulation on top of rack switches and introduce new signaling protocols like EVB, for example, which is more of the same that we are doing. And it's realistic that we can deploy new hardware to support whatever new virtualization technology we want to have, for example. So is overlay the only answer, or is there something else?
It's the easy button. How about
Yes.
that?
Yeah, it's get out of jail card.
Exactly, right? So it solves the problem. It's in reality, it's nothing new, right? We have been building overlays for the last, I don't know, since the internet was invented. A layer 3 network is an overlay on top of a layer 2 switched network, and it has always, a backbone is it used to be an overlay over SONET, now it's an overlay over WDM. So it is the way we do things, right? You create layers of abstraction, and sometimes it's one form of indirection, and it solves all problems other than too many indirections, right? So it's just one form of indirection that gives the ability to create a solution that has been tested, right? It is known to work. We know it can scale. And fundamentally, actually, the big thing that it does is it decouples the evolution of the network from the evolution of what do you do at the edges of the network, right? And that's what the internet is all about. It's all about end-to-end. It's all about pushing complexity at the edges, keeping the core as dumb as possible, as cheap as possible, and let's move on with our lives, right? So I don't think that adding intelligence and more stuff in the network and state in the network and this and that is the answer, right? Let's keep the network simple.
I mean, I would say that overlay networks, the next step from there would be to build solutions on top of it. Like, we are very excited to figure out how to solve for business continuity disaster recovery using VXLAN as a vehicle, right? I mean, if you think about people, I mean, storage guys have been talking about how do you re-IP a VM on the other side when you fail over and when you fail back. It's like these are problems that can perhaps be considered for the first time if you can really get a robust, reliable overlay network done where you don't have to think about different boundaries and different subnets and different address spaces and so on. So I think just building solutions on top of that by itself would be a multi-billion-dollar market, if it can be done right,
Yeah, it seems like, I mean, basically we're talking about virtualization, right? This decoupling. We want virtual networks. that's going to require layering. It required layering and virtualizing the server. If we're layering, isn't that an overlay? I mean, it seems like if there's any way to provide a virtual network, then why wouldn't we call that an overlay? So to some degree, it ends up being vocabulary, right?
So, I mean, so we can do a lot. So, you know, this idea that we have to have an overlay, I have to jam traffic into a VXLAN to do anything different in the data center, I think is kind of wrong. Because I think fundamentally, to get away from the fragility in networks, like I need the ability to say, I don't want any packet to go on this network unless I want it to, right? So, I mean, that gets back to the state problem, I think. But I mean, even today's hardware, there's a lot of things that you can do with 1,000 flow rules. It's not necessarily even the hardware today that's missing, it's software. Where's a controller that I can do this with? Where's solutions from vendors? I mean, they're far and few between, in my opinion. But that's the cool thing about right now is if you're in the community, you can say, I've now got this ability to code out my own solution. Because I think SDN is kind of, it's much more than IP mobility that we're going to get out of overlays, right? You know, one of the biggest drivers, in my opinion, is some of the hyperscalers that are saying, I can program and control every single part of my data center except for, you know, the mainframe that is the router in my data center. I can't do that.
Yeah, I think my point is that, you know, network industry has seen a lot of these kind of massive hypes that resulted nothing. Like ATM was one such, you know, and IPv6 was another one. So you just have to figure out how to take one thing and do it well.
But isn't a lot of that innovating in hardware as opposed to innovating in software?
Say that again?
It's innovating in hardware as opposed to innovating in
innovate in anything. I mean, I'm just saying that we don't have to look beyond overlay networks. Even doing that right, because right now SDN companies are struggling because they don't know what is that spearhead where they can go and make some money. Right? Because it's about boiling the ocean. It's about, you know, let's go and really do this Hail Mary and everything will just change. So I think doing that right, focusing, building solutions on top of it, figuring out how to work with storage companies, compute side virtualization companies, you know, getting that one thing focused right is perhaps the right way of, as opposed to saying, well, is this the only way? Let's go after two more ways of doing it.
I think it is where it is ending is on the virtualization abstraction plane. So like you said, it's finally all at the same at the end. It's the end-to-end paths you are creating, whether it is using a fabric type of an approach or a overlay approach, and then you're just creating different ways to connect the endpoints and with different flexibility. Who knows what are these styles and which I should focus on? I mean, whose style should I focus on? But at least what I see from interacting with some of the customers is that there is a need of unification on the top layer that at least creates one single virtualization plane, because finally the orchestration or the overall system wants to interact through a common programmatic interface and may adopt different styles based on a particular use cases for that particular data center. So that, I think, is lacking, and that's where that unification should start gearing towards.
I think it also depends on what problem you're trying to solve.
Imagine.
Certainly for certain use cases, if only we had IPv6. Each thing's uniquely identifiable. You can manage connectivity ACLs between all endpoints. You know, but then there's, you know, it's where we are today, and what do you want to roll out in your existing infrastructure? And that's the biggest appeal of an overlay, is you get to reuse a lot of your infrastructure that's already there and sort of incrementally move towards, you know, what may be, in terms of low-level protocols and technology, something that looks quite different from a VXLAN type overlay that we have today. But you know.
Yeah, and I think, you know, the industry right now, the problem with networking industry right now is it's a monopoly. There's one large vendor that controls 70% of the market, and unlike storage, which is highly fragmented, so you can actually create disruption in storage, because again, you can go and deliver a bubble which is $100,000 worth, as opposed to, well, here is something that will cost you $5 million to roll out. So there is promise. I mean, I can think of how the database world was like this, and then open source happened, and it took like 10 years for it to get to where it is today. So people do analytics and warehousing with software and Hadoop and things like that. So I think there's promise. It's just that it's going to take some time, because it's just a very unfragmented, consolidated industry today. You know?
I think that's a good point. It's the whole premise is is also built on how much you are creating an open data plane, so that the ecosystem participation becomes much wider as opposed to driven by a single vendor type of a company.
By the way, now that you mentioned IPv6 as a new technology and you mentioned open, I can't resist throwing another open thing into the mix. How does OpenFlow play with SDDC?
It's an implementation detail.
Okay.
Exactly.
I'll go with that.
Yeah, it's hard to argue with that at some level. I mean, our friends over at VMware and Nicira, right? They say we'll just do it at the edge, and you know, they certainly don't have to wait for hardware if they do it that way. And like we were talking about, just run it on that old school network. Let's not worry about the performance, you know, in those gateways. And in that model, they're running something that sort of resembles OpenFlow, but OpenFlow has gaps, and they're not contributing their solutions back. Some of it's open source, so we ought to be able to go extract it. But I don't see the folks that are doing that. That happens in a different working group than I participate in. So essentially, it boils back to it's an implementation detail. You could do parts of it with OpenFlow, or not.
I think it's too low level vernacular. Actually, it's like NVMe and PCI Express and stuff like that. You know, you can still innovate in Flash without even thinking about what NVMe standards are going to look like and what the SCSI Express standards are going to look like. You know, they'll take their own sweet little time, and I think the hardware vendor is going to come around and figure out how to support all that. But you can still do things on top without having to wait, you know, for that thing to actually become a standard.
Sure. So it might be a different answer in a few years, but I mean, Amazon's doing virtualized, you know, SDDC. I don't think they're using OpenFlow.
Yeah.
I mean, to a certain extent, Nick McKeown said it right when he started the whole thing, right? It's the assembly language. So, you know, there is an instruction here, instruction there, adding, removed, whatever, but well, who cares?
Yeah, so I'm going to push back a little bit, because I think there's, you know, there's a lot of value in decoupling. So, you know, and so when people think of OpenFlow, they think of, oh, well, the packet's going to, you know, new flow is going to come in, it's going to go to a controller, and now I'm going to have this huge amount of, you know, latency. And it's just wrong, right? So OpenFlow is just another, its implementation is just another access on the state, right? So I can either push it proactively, and I've got this eventual consistency. Guess what else does that? BGP, right? There is no difference. The difference is I can now have L2 through L4. So how else can I say from this server I'm going to install L2 through L4 application-aware flow policy?
Yeah,
I mean, tell me how, because I don't know. OVSDB maybe someday, but I'm kind of tired of access lists.
I mean, but
Mac VLAN access, right? I mean,
but it's a low-level assembly language, right? And
it's for developers.
We had
it's a developer tool, though, right?
It's a tool, right? It's a valuable tool. It can be used in some instances, and it's very useful in some instances. But that's what it is, right? It doesn't solve the bigger problem. What sits above it.
I think the contention is around the whole commoditization of the hardware that it can bring, right? Yeah, because we expect interoperability. Yeah. Vendors don't. We do.
I think the final it lists only one thing. That is just creating an open data plane. Everything else is implementation, essentially.
Sure. I mean, actually, I think part of the problem that OpenFlow has is this myth that of the instruction set. So yeah, I agree that's what Nick has said, but not very many people write code in x86, even when it runs on an x86.
That's true.
It's not a strategic, you know, protocol. Let's just say that it's going to happen. It will happen, but
there needs to be some adjustments that happen to the model, you might say, the life cycle of an SDN, and I don't want my controller sending down changes to my data path that willy-nilly. That seems like a big risk profile. So there are some folks like me that argue for a slightly different model. Let's call it C instead of x86, and have a compile.
Sure.
And I guess we're running out of time, so I'll just throw the last question in here. It looks like every vendor that's offering something that's close to a product in software-defined data center is trying to emulate the past. So everyone is talking about layer 2 segments. Everyone is concerned about unicast flooding so that Microsoft Network Load Balancer will still work. Well, everyone apart from Amazon and Microsoft, that is. So what's your take on that? Is it time to sort of clean the slate and move forward, or do we have to support all the 50 years of legacy with software-defined data centers and be burdened with that?
My impression is that everybody's trying to figure out the 80-20 rule. You know, what's the 80% of the market I can get with 20% of the functionality? And you know, different people are picking different 80s and different 20s, and it's not exactly converged yet. Mm-hmm. But I think once it converged, yeah, we'll chuck a whole bunch of functionality that is a bit passé. We'll move toward the Apple model instead of the Microsoft model. You know, so oh, sorry, your printer doesn't work with our new OS. Get a new printer. You know, I think that's what's going to happen.
Yeah, I wish we could throw away all the stuff that are too complex, but it's a whiz, right? The reality is that you are being forced, and the more you get deployed, the more you are being forced. Add this feature for the Microsoft load balancer, add that feature for Apple Talk, I don't know, whatever else, NetBIOS, whatever else it's gonna come, and that's reality, and then it becomes a feature creep, and resisting is very important, but
it's futile.
But it's futile.
I mean, even a company like VMware, which was doing next generation stuff, had to really go and emulate a lot of legacy devices for it to really be accepted in the marketplace. So, I mean, if you can bridge the legacy, then you can be a very large business. You know?
Yeah. I think it's critical to have some support. It's tragic at the same time. We really strive to move away as much as we can from these low-level primitives, but we get pulled back by our customer requirements. I think the right answer is in part in the software solutions that we deliver that allow you, as maybe a newer user, to take advantage of simpler abstractions and not have to fuss with the low-level implementation details of, is this layer 2, is this layer 3? You just want to define some fairly simple groupings and some policies, and not really care about the implementation details as a user of an SDDC system. And in the underlying infrastructure, as technologists, we'll be plagued with the hard stuff for a while, but Amazon's already shown that you can move away from it. It's just a question of how ubiquitous can you be with that move.
I think that's the point. Like, I think Amazon bring that picture. It's like we were discussing the applications. Can it use the underlying infrastructure in a much better way to either increase availability or scalability, or like use, let's say, the new elastic scalers, both load balancers and other appliances. So it all depends, I think, more on the economy of scale, that what business the particular company is working on. Does it make sense to use those, or just stay in the legacy zone? Yeah. Like a company like Netflix might want to do that because he sees an economy of scale by doing that, but maybe not all. Maybe they can just stick with the legacy standards and not want to change disruptively their whole application to use that SDC interfaces.
Okay.
We're all pumpkins.
Thank you.
Thank you.
Thank you.